So, how do we get this first context? Let's have a look at the different evaluators, it's called, but it's not that complicated. You have OCL, that is running in memory, great for working with small short things in memory. You have the OCL executed in the database. That's how we get a foothold or find the first object. And then you have the echo action language, which is very, very similar to OCL, but you can do stuff. You can change the data. OCL and OCL PS cannot change data, can only find data. So if we remove this, what will happen here is that it will read all the person objects into memory. And if we do something here to select something specific, they will still all be loaded into memory, and then it will be picked out. For example, if we add here, we select on a person's name. Oh, it's called first name, I think. And it should be equal to Peter. And then, what's wrong here? Oh, we need to add a little thing there. You see, we have a collection of persons. How many? Only one. But it's still a collection. A collection of one. Now, this is extremely inefficient if you have 1 million persons in your database, because you will be loading every single one into memory and then find the ones with the first name of Peter. So instead for running this, we'll be running it as OCL PS and run again. You saw it took a little bit longer time. That was because we forced the framework to call to the internet all the way to the Azure server, to the SQL server, and retrieve this specific object. So right now it was slower because we needed to go to the server, but if you have a lot of them, you don't want them in memory, so we just get one. So this is how you get a context. And then you could of course add things here like family and run the evaluation again, and you will get the family. So why not always use OCL PS? Because there are serious restrictions on what you can do with OCL PS. It has to be convertible into SQL. So when we run OCL PS, what's happening is that this construct here in OCL gets translated to something like this. And then it's run. And although it's in the framework, so we'll get a family object back. But you should restrict things to just finding objects using the OCL PS. Here we have so few objects, it's no problem running it directly in OCL. You see, then it's instantaneous. And one of the things that's important to understand in the difference of how you construct applications between SQL based and OCL based, and I should say view model based, because most things are run as view models for user interfaces. It's only searching is done with OCL PS, and the things that goes on within a view model is written in OCL. Now, in a SQL-based application, it's often huge queries that actually returns basically the whole user interface. Each row is very large. And if you have nestings in your user interface, that is several parts, you try to combine them into one SQL, or you are forced to make several SQL calls, and that's an extra round trip to the server. In MDriven, using OCL, the OCL statements are usually very, very short, and then the view model engine creates the queries and runs them efficiently. So usually there's not really slower running using the view model engine than using SQL itself. Now, let's use a few OCL PS expressions. Here we have the basic statement, person, all instances. You always, you could say, use all instances. That is like the from statement here in SQL. Then in SQL you put the select statement first, that is what columns you want. You don't do that in OCL, you don't put it first, you put it second. And usually you don't select the attributes in OCL, you just select the object, and then you use the attributes you need when you construct the view model in the user interface. But you can pick out a specific attribute. So now you have a collection of persons, and you can pick out name, for example. And now, we have first name, and now you have a collection of strings, and if we run this, you can't, because we can't pick a specific attribute with OCL PS. So we restrict ourselves to just filtering objects with OCL PS. How do we filter object? Well, we use the arrow, which means you're on this collection, do something. Well, we want to select, which is not the same thing really as in SQL. The select statement in SQL selects attributes. In SQL, you write where. And the where statement in SQL is the same as a select statement in OCL. The where statements in SQL, they can use, for example, where p dot something, like first name, and then you will filter on that one. This p thing is the iterator, or the handle, you could say, to look at each of the person rows here. Here you also need something for the OCL to have a handle, to have a context. And you can name that anything. I can actually write anything here. And then I have this pipe, and then I use anything again, anything dot first name, and then it should equal Peter, and that again. So in this way I get all the persons, and I select, and I identify every row. I call every row anything, and then I use anything dot first name equals Peter. Now this seems confusing, so let's use P instead for person and try that. Good. We got a whole object, a person object, or the specific type of person object called adult that had the first name of Peter. If I do the same thing here, it's the same, and run this, I'll get the same row here that matches this object. Here, although, I got the family information too. Not as an object, but as more attributes. So, how to think about this? Well, you always start out with getting the collection in OCL, and then you select not the attribute, you select the object. Here in SQL, you're used to selecting attributes, which you don't do in OCL, and you say from something, which is what you put first in OCL. You join stuff in SQL, and you have where statements is called select. So what about the join here? Well, you can join here by putting a dot, and the dot, and then follow the link that's called roles here to family. And now you will get a collection of family. And now maybe you're thinking, wow, I lost the person objects. Well, not really. You first picked out the persons, and then you got the family object connected to each and every person. So, okay, and run this, and you get Peter's family object. This means that in OCL, you don't join tables or classes together. You can't do that without creating what I talked about earlier, a tuple. That is a suddenly created class that contains attributes. And I'll show you how to do that, but it's not as useful in the MDriven framework as it is in SQL, or as you are forced to do in SQL, because we use view models instead. Now, let's make this a little bit simpler and remove the join and look at some more features here. In SQL, you type, for example, first name and last name here. And you can have a where, but let's remove that now, and you do order by, and then you type something. You can either in SQL type p dot or just a name, but for clarity, p dot last name, comma, p dot first name, and let's run that one. Oh, order by. And you get the first name, last name, and you get them in last name order. Okay, how to do that in OCL? Well, we have person all instances, and we don't need to do any selection anymore, so I'll remove that one. I have all persons, and I do order by. Case is not important in OCL, but it's the default way of writing things. And then we can do the same here. If we want to use p dot notation, we need to put p first to tell the OCL parser that we mean for every object in this collection, that is the person object, call it p, and then we have the pipe sign, or a space in between, pipe, p dot last name, and we do the same if we wish to have first name after that. So comma, p dot first name. Okay then, and here we get a collection of person. So we run this, and we get the exact same thing, but here we get objects instead of these things here, which is rows with two attributes. So why why wouldn't I just want these two? Well, these two are just attributes. The SQL Server don't know how to change them. You can't just start edit things here because the SQL Server don't know how to write them back to the database. In our case, if we have objects instead, if we change something here, the underlying framework knows exactly how to write that attribute back to the database because they have not lost their type. And because they haven't lost their type, it's clear for the framework how to write data back to the database if we change it. And that's also the strength with view models, where you don't lose this type information about how to write back to the database. And then of course we can combine things. You can write person all instances, and then you can, for example, select on something, select, and you can use the same short iterator, p dot something. Let's use last name because that's are several people with the same last name. And let's just finish this off so it's syntactically correct and write Johnson there. So this is find all persons. On that collection of persons, pick the ones with the last name Johnson. And then order them by looking at each and every one and looking at first last name and then first name. Okay, running this. And you get the same people as we would down here if we were looking for the last name. So let's do that. It's called where in SQL, where p dot last name equals Johnson, and run it down here. The same data. We got Gretchen and Peter, they're called Johnson. Now, these things are functionally identical. You have this one here, that's basically person, all instances. You select what you want and then you order them. The same thing as here. Here we have selected just the first name and last name, but we can easily get the whole object, although it is just more attribute. Like that. Now, let's make this a little bit more complicated. By selecting not on the last name, let's navigate. Let's say we want to check if a person is a part of a family, and that family name is Johnson Anderson. So let's go to family dot name equals Johnson Anderson, and then we order it by this one. Let's do that. Well, that worked. We got 4 people because they're all part of the same family. And you see, we're still getting person objects because it's only the select statement that kind of like peeps over to the family link. For each person object, it navigates to family and check the name attribute. If you look here over there to the model. If we want to do that in SQL, well, we have to join. Maybe I can get back the statement before. There we have the left outer join, but it can't be a left outer join anymore. It has to be a join. So if we join to the family and the family's name is Johnson Anderson. Now that should be all the person attributes for that family. So that's equivalent. But here again, I needed to know things about how to do this and how to join them together. Here I didn't have to know that really, because I just said, go to the family and have a look. So I think this will conclude this session, and what you should take away from it is that each class is a table. OCL PS is a way to find things in your database. And when you're thinking, I want to get these 3 attributes, you're probably in the wrong place when using OCL. You should probably be thinking, let's use a view model, because view models are specifically created to picking out the attributes from one or many linked classes or objects that relate to each other. So instead of creating huge SQL commands that picks out the attributes and constructs them and returns them to you as rows with columns and attributes that are actually disconnected from their source in the database, you create an OCL PS that finds the root objects for view models, and it's the view models that pick out the attributes. You use OCL to select and find the correct objects, and you use OCL in your view models to navigate and find the attribute you're looking for. So in the next session, we'll be looking at more specific OCL constructs for working with attributes.